Yes. Good evening, everyone. Thermal properties of matter how gray. So last class previous class the queen na give to yang see a screen share to again. Yang So queen previous class the sorry see na take previous class the queen to queen have the see get to gray thermal properties of matter to gray. Coefficient of thermal expansion linear area wise volume wise then expand over then coefficient of linear expansion coefficient of so coefficient of areal expansion and coefficient of volume or volumetric expansion so and how are these constants related to one another hierarchy you get this alpha v is equal to 3/2 times so alpha L blah 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 so so I see the conjulam gadra khangde so adumine like so CC a previous class ki video do upload to bane kay the Wi-Fi yada bagi and mobile data am unstable over marang na CC class na CG class loiraga previous class na CG class ka gi punna upload to now within the measurement of temperature the queen we have the some key points at 0 degrees Celsius Fahrenheit and 32 oi Kelvin and 273.15 melting point of ice and then 100 degrees Celsius or boiling point of water at normal pressure Fahrenheit 212 degree Fahrenheit oi and Kelvin and 373.15 Kelvin oi now high data sing this is in Celsius Fahrenheit labor relationship habadi any temperature in Celsius Fahrenheit pamagadi kamine togani habado CC formula the layer formula Celsius degree Fahrenheit degree Celsius to degree Fahrenheit kamine convert togani this is the formula and the coin shadoraini and the solve example then degree Fahrenheit degree Celsius to on ge haragadi pyramid degree Fahrenheit value do y mapada plug in toxelani and tarai poto degree Celsius tarakani buka so see the formula and see the solve example solve so that's measurement of temperature and then in previous class the heat capacity in a gray heat capacity has have the any substance have the regardless of its size quantity matter blah blah volume doesn't matter any body magi 1 degree temperature see rise or raise toxin so to the heat required to raise the temperature of a body by 1 degree Celsius CCB heat capacity so we have the magi quantity obviously more heat will be required to raise the temperature by 1 degree Celsius and hence heat capacity will be different for different amount or different quantity of the same matter but specific heat capacity hierarchy it doesn't depend on the size or volume or mass. Why? Because it is divided by per unit mass. Have the unit mass just 1 unit mass heat required to raise the temperature by 1 degree Celsius on a specific heat capacity of water has fixed like aduga heat capacity of water has fixed like sir water kayam low do know question but specific heat capacity of water has so that's it so mind on a specific heat capacity of anything it could be any steel it could be whatever any object any substance copper logera any alloy logera any plastic again different types of plastics are there whatever any material any substance give my heat capacity and heat capacity specific capacity so last class the cover measurement of temperature then thermal expansion specific heat capacity now today we'll do calorimetry and change of state and heat transfer so I think we may be able to finish this chapter today and Newton's law of cooling it's a very small topic live pick the topic ni but heat transfer is the radiation kitang fazana explain tawningi sir na so radiation explain tawudang si class mali but again change of state calorimetry live topic ni sir explain tawge muna taro So sidam continue to tharasya. Yes, dum to na pare but okay fine. So mayam amtang sir kamtang hange sir nangang isi mayam loin tabra. Lakshmi, Sunanda, Anjali tabra sir nangang isi.
Tayo sir.
Tai ka. Okay, okay, fare yeah. Kasorji ka. So mina hajik tawbudisi kaino habda calorimetry ka. Calorimetry si noi hanadai khangba mi yaubra. Khangbra dum hanadai khangakbra. Khangbro? No response. Kaino kanam to respond to upsi ja. Lakshmi khangbra handagya. Sunanda.
Hypothetical niya sir.
Hypothetical khangya ka. Okay, fine. Now, calorimetry.
Hit loss.
Peba?
Hit loss. Hit gain ga mana na hypothetical adudi khangye sir.
Yes, exactly. Have the energy se amarom the energy can neither be created nor destroyed. So the heat loss is equal to heat gain. Heat loss by the body at higher temperature is equal to heat gain by the body at lower temperature. That's the basic principle of calorimetry. So let's say heat gain by body at lower temperature is equal to heat gain by body ay sis ngatang kano to ka height to ge dun farni so tang se height to ge by body at high temperature na sma height ne ko aduna habidi kaino habada kaino sida le ni ko delta q ka heat ke dawa gain hage ka so delta q harga heat gain g a I n ka heat gain again c g a I n e d is ka so heat gained sida ed ogiramnika and sidana heat lost hagadam. Why do I do that? So it should be here. Again, see someone something again. Heat gain and heat lost. So heat gain is equal to heat lost. The delta Q lost. Yareka. So CC equina kidawi hamatamda now akoina kai khangi have the ka S specific capacity is kai gamane have the delta Q M delta T gamane ka or I may write delta Q M harga T1 minus T. Manli ko have the higher temperature to low temperature ne ka. Let's say T1 is a higher temperature higher ka get by body at low temperature. And okay, anyway, I na pa mo the ego DRS. So delta QC, can I write like this? S1 M1 erga T1 minus T is equal to S2 M2 T minus T2. Yabra sikisa? Yaning bra?
Yes sir.
Yes sir.
Okay, fine. So this is the basic principle of calorimetry. Ka. Now, sidagi kedawi ham tamda body 1 gi magi specific heat capacity piramani body 2 gi specific capacity piramani body 1 gi mass body 2 gi mass piramani body 1 gi temperature piramani and body 2 gi whatever final temperature piramaga aduga moini gi common temperature puthokpa yai natraga common temperature piramaga ngasai gi kedoba ngasai body 2 na lemba temperature du kyano or body 1 lemba temperature du kyano adwain to rakhine numerical problems mayama design to be based on this equation of calorimetry you have to be very thorough with this equation so that's calorimetry kashu kyam luba pot natte calorimetry as yamna live kenoni yamna live part amne heta no idum yam line ngamni so that's calorimetry aduga noina khangjan gadaba amna calorimetry sometimes you'll find some terms such as 1 calorie is equal to 4.18 joules, which is equal to 4.2 joules. And they so makatogzi calorimetry lere makada kay lay change of state lay so change of state ang torsi now change of state ta kay lay have matam da change of state hay si kay no matam da state ahum lay dana solid liquid gas na aduna any substance amasi my state state ama change to matam da changba heat to adudubu kaina latent heat ko eba change of state ta kaina study to budu si kaina will study latent heat never so latent heat si ani lay latent heat of fusion haibama and latent heat of vaporization haibama yare and then so first we'll study latent heat of fusion LF is equal to, again it's the same thing latent heat of fusion is delta Q by M and you'll have latent heat of vaporization latent heat of vaporization LV is equal to delta Q by M. Now let me explain suppose let's say you have there was some quantity of ice see container see that you have some quantity of ice now sigi ice dane aina kaygumba heat si thazalleba here I give some amount of heat delta Q amount of heat si thazalle haitare then heat ma'am thazalle so heat thazun matamsida kaidoni have the ic kaidorakani
melt tawraktiba
exactly melt tawrakani aduga aina heat si ma'am thazalamnina ic melt tawrakuma temperature ji hengalakadra as the ice starts melting will the temperature increase
no
Lakshmi aina hit sa aina ne ice khara freeze tay lawthuebako ice cube khara aduga steel gi kayani suspend natragana saucepan haibra adu natrana any kayani metal gi or alloy gi any bowl amda hapaga aina kaino the gas stove mathakta heat si tharaga thammeba ice se mai thare haitar haidi ice heat pisallebako gas stove mathakta thangalaka ice jarlong melt torkaneba so ice melt over ho matam the temperature ji kya laini increase to kadra to roidra or temperature ji kya da laini yes Lakshmi haro Lakshmi tabra Lakshmi ji ta da male ko Saila tabra
Sir, 0 degree Celsius to lay down.
0 degree Celsius lay dong male ko Anjali tabra
Tai sir.
Temperature ji aina hit to matam da ice melt to hor ko du temperature kya da lay ni
0 degree Celsius.
0 degree Celsius ta ka okay fine so Sunanda temperature ji karam kanda 0 dagi kakalakani no ji tadra male class e no NEET ngai trio na ta dira temperature okay fine Anjali temperature is 0 degree Celsius te karam kanda kakalakani
Latent heat of
no
student do adu do lower.
loinemak melt over lower kanda kakalakani hayo gyantai ka as long as the ice doesn't completely melt ka habidi ice just maruk kane ice makup amatang yaur phobudane temperature increase sung to roeba and ice completely melt over kan temperature 0 dagi 1 2 3 4 sum kakalakani bu ko but as long as ice makup ama yauri phobuda temperature adum 0 da laineba adudi aina thazangriba heat mayam du absorb ti tawragasu temperature increase tawda result tawde it doesn't result into an increase in temperature haita the amount of heat absorbed doesn't result into any change in temperature or any increase in temperature so adugi heat absorb tawida kaido buda haidi sir haidi energy di absorb ti tawrineba tawragadi some temperature da increase tawrakam thoeba ko but temperature increase tawkai tawrakteba audi kai de sakra gain hang matam da adudu neba latent heat haise temperature change sai biya deba just audi sir kai chakra hargadi magi state change tawdo in seasoneba haidi ngasagi solid state tagi liquid state ta magi bone energy blah blah adu myam du loinamak redistribute tawrakadoineba ko my structure do change tawrakadoineba auna adu sing du da energy season gibagi use up to gibagi my temperature se increase to wangam dabneba ko state change to by energy am changeba adugi energy du latent heat ko weba aduna latent heat ta di state se change to kane state haidi kai solid to liquid ogera liquid to gas ogera gas to liquid ogera or liquid to solid ogera whatever whenever we talk about latent heat kedowa a change in state of matter is kedowa observe haigera ko or takes place change in state of matter takes place but there is no change in temperature if in case there is change in temperature adu latent heat natre latent heat nataba kaidowa chumnagi normal heat to ngasagi akoina heat capacity lom da la ani ba ko kaiguma temperature increase or decrease tawrokpa taragadi but temperature increase decrease tawroktaba heat ti adum pisan ba adu temperature increase decrease tawroktaba adu di kaidowaino habada state change to the season gibaini haiduneba so state change to the season of heat to latent heat ko eba ko sunanda tabra Lakshmi
Tai sir. Sir.
Hello.
Sige ko latent heat ki fusion agra vaporization agra ani ki definition piwa gando ko constant temperature haina hari dong sai ki sir na even single ice to melt loinama completely melt out dragadi temperature increase to have do adu dugi ko hadi adu da season age bagi constant temperature haina hari oidur
hoi hoi habadi temperature to increase tawrak naba heat to lem dreba kaino di hana ne state hana loin change to no hona ne ba magi nasagi solid state lem do liquid state ta change to ma ta na magi structure do change to wise magi bone energy blah blah hadi adu myam do redistribute to ka do ne ba solid te liquid ta lakpa matam da auna energy ina pisali ba myam do loina ma use up to wa haitare aduna mangonda temperature increase to no energy amta lem deba adu loi digai temperature increase to ya deba auna state se hana completely change to neba auna liquid hadi kaideba ice marik ambo yaw ya deba makup ambo yaw ya deba habdi yawraba temperature increase to roiba auna ice completely melt to re har kanda temperature je amu increase to kaneba adudana heat capacity la aneba gyan tarba
tar sir
tare ko adumaina tawdana latent heat of vaporization haiju kedo ya nana water ji 100 degrees Celsius le re adum heat pisalo adum heat pisalo ba 100 te sungen helo ya roiba normal kaino dani ko pressure dani ko haija ani normal atmospheric pressure da haita nangna adum pisalo heat phanam pisalo adu kedo 100 degrees Celsius helo sunga ya roiba but nangna heat tu kai gumba iron gumba da melting point yam wang ba iron gum pisaladi heat pichal in 100 and 1000 2000 degrees Celsius yorkaneba, but water the 100 helo sunya yaroiba. How this sir, I pichal heat me am do the kai chakre hargadi madu steam the convert to ko. Ganta right on a state change over the season, on a state change over the kedoba season of heat see temperature the kedoba temperature change thon de ko on a temperature to 100 degrees Celsius. Ngasai water, boiling water at 100 degrees Celsius to steam at 100 degrees Celsius to they are both at 100 degrees Celsius, so they have the same temperature, but energy wise the steam na yam thine he level energy je ko kai absorb to griba heat me am do adu do possess to the name steam jida adu na ne ba koina ga kai do we have the ising asauba chong baga ising sauba steam do na theng baga pokpa je steam na yam thine hen mane pokpa 3rd degree burn no even steam na pokpa yam saba ne ba yam thu na ju heti ke do wa ai sokpa do hen mane ba ko steam na sokpa ga ising asauba chong baga steam ga na kai no ha matam the steam possess a very high latent heat of vaporization hai ta gyan tai ta de
tai sir
tai ka so adu maine lai de aduna now so noigi keno view in a exam point of view in a latent heat of fusion of ice and latent heat of vaporization of water in a ka cc noi khangjan gadam ni si values e ka adu hoi pekha the most likely piram gani ka p the batars no idum si si khangjan gadavani keno da kedoba as kari magi keno unit SI unit ka kaiga amana centimeter gram CGS unit ka hatare ko centimeter gram second ga adugi du da ID in terms of calorie hatare ko and in terms of joules da khangjan gadam ni ko. So let's see together ko koidum yeng this sir su kashum to sigi kedo wasigi number je kena to de ko chimpa pu de hatare. So but noidi pu ko latent heat of fusion and vaporization of water. So latent heat of fusion approximately 334 joules or 79.7 calorie per gram degree Celsius. So C values have it 79.7 calorie and 334 joules. Okay, was it 79.7 and 334 joules So for natraga my eyes yeah, okay, fine, yeah. Easy for ice, latent heat of fusion is equal to 79.7 calorie or kya 334 joules 334 joules. And then for water, latent heat of vaporization is equal to latent heat of vaporization 533 and 2230 533 calorie or 2230 joules So that's it. CC we have the CC na 800 degrees Celsius ni and at 0 degrees Celsius adu dumuzu kangjalu. Let's move this a bit. At 0 degrees Celsius, at 100 degrees Celsius haitare ko sumaina sigi value base sum khangjan ba phai ko again this is 4 haini ko yarba myam sigi za yarba
oh sir
yare ko
Yeah, sure.
sita boss yabra
Yeah, sure.
okay fine now let's proceed guys koi change of state loire tak ko mathang the heat transfer ong tor ji ko heat transfer de ne myam na struggle tong nai se ko so sir ta age heat transfer yamun na taw heat transfer khang ga di ne no heng wai geography ga paab da yam thina nungai ge da ne ba heat transfer khanga di. So heat transfer si there are three ways in which heat is transferred hai tare ka. Heat have the energy in transit hai ka. Have the higher temperature body the lower temperature body the energy transfer to in the form of heat transfer to ka. Now there are three ways in which heat can be transferred. Adugi three ways to kai no. Have the number one the conduction. I sumana irrigation space unnecessary the space mangi. I'll just use like this. Heat transfers. There are three ways in which it can be transferred. So the first one is conduction. And conduction layer. Second one is convection. And the third one is radiation. Yeah, so now numeratagi kana haidi conduction ga convection ga radiation ga kai khena ba hairo si hom sida.
Sir, conduction gi formula sina solid ta kakta sijina ba?
Solid ta kadang sijina ba conduction jina ka.
Aduga convection na liquid and gas ta.
Hmm.
Aduga radiation na vacuum and airs ta.
Okay. Atopadi kana kai haningi conduction convection radiation.
Conduction gana heat transfer se without the actual movement of the particles or the
Okay.
Convection dana with the actual movement or the radiation haragana source amadagi at the same time the heat transfer to the radiation
na hajikido last kido radiation haragadi kayeba source amadagi at the same time transfer to over the particle or matter yaudira.
Without the necessity of the medium.
Medium, okay. Medium yaudragadi sineba ka. All right. Atopadi. Okay, habidi atopa nui khenaba point gumba lay hiding ba lay riba lay treva ka. Okay, fine. So heat transfer to oversee ngasai ke source sink or whatever higher temperature the lower temperature difference lay trigger heat transfer lay roi ka. So quite first the prerequisite haigadra abdi kani quite first the kari han lay gadam have the temperature difference lay gadam ne ka. Now body ani the temperature difference layer adu we have that they want to achieve common temperature or equilibrium the labor palm aduna heat se them transfer to kaneba the conduction higher gadi kaino ha matam da koina yes as it sailana hagiba solid ta tawin have do it's not necessary that solid ta khatang tawni have the adudi amuka leite ko have the kaino ha matam da even liquid to ergasu we have the conduction to we aduda we have the again in general liquid the fluid says liquid oigera gas oigera moisi convection to weba convection to is kaigino ha matam moisi expand to raga moisi lighter oibanina habidi kedawni ha matam da moisi lighter oibanina moisi matakta kakhalaga denser oibda makha kumtharaga adumain to convection to weba ko so sahilana haiba definition du karam kanda chumi habdi magi kahne mangun the constraint khara yaweba saila tabra tai ko like the budi yor mo sigise nuni extra knowledge pa magadi kaigino convection jida sarna haidi nangna haji have to liquid to chumme ko but adum chum rai chum deba nang kaigimo space to chalagadi international space station the convection to ya roiba gravity changeba convection to ge haragadi ana gravity laita mafum the convection laiteba ko auna adudadi kedorokani liquid to su conductor kaneba Sarna haining is the Gyanta Ngambra Ngamdabra. Sarna has Gyantabra.
Sir.
Like okay, again, Sarna has say Lakatanginate Anjali Lakshmi say the boss Sunanda, Luin Gyantabra Sarna Jagrita. No response.
Yes, sir.
Taika. Habidi conduction in general solid to Taweba. Now, conduction has the Kaino Hamatam, the quite live in example haragadi nangna candle or gas stove amada nangna yopi am hai tare ko gas stove da mai je somgi it has two ends natra so one end jinna mai da kin tok salo ko kedoba mai da thau hai tare ko adu ergadi 1 second aina ji let me just stop sharing just for a few seconds ka now kido we have the conduction haragadi let's say aina kedoba candle lam le candle the si sina kaina sisina kedoba yot ki keno rod amaneba natragana yopi amaneba ka this is a nail ka an iron nail and aina kedo we have the candle the si hit tawreba gas method audi som site saram masing hagleraga kedo kane som site su sarwoidra heat si kedoba transfer torokane ba so sigi mode of transfer of heat si conduction ko means the heat energy is conducted from one part from one end to the other end or from one part to the other sida iron ji kedowi movement over iron gi matter natragana particles sing ji move over deba so this is known as conduction when haidu chumi this is conduction now convection the gravity later the convection to ngam deba Now, convection agadi, for example, let's say na sida yauriba water zina kedoba boil toreba sida heat pireba adu agadi so ida bottom the heat phangiba water gi kedoba saruk se maji kedora kane heat phanga maji kedorani expand torane so my expand tor di kedorane my density is lower neba my density lower di kedorane ma lighter or mathak kakat krani mathak ki heavy obviously ma di expand tor domni na mathak ki kumdara neba so sumain torga ma amuk hit torne ma expand tor di kakat krani the expand tor di density light oiba ko density less oreba adu he mathak ki kolo obviously na mo heavy obe hen bagi on tarani amu hit tor di kakat krani sumain tor continuous cycle ma lege do neba so this is known as convection kaigumu gravity lairam daba targadi makhagi je kedo expand torni but mathak ta kakat ningaro kaigino di g laitram na weight have the laitram aduna di kedro kani conduction no intorga adum so c yor kani bi che gyan tai ko so but liquid see in general akoina earth natragana gravity lai mafam da hit to matam da convection na taweba ko so that's convection gyan tabra jikido ma'am tai ko and then radiation hargadi electromagnetic radiation ni it doesn't require any material kedoba abdi kahini haidi ziki nasagi haigi bido sunandana source ka kahini sink haini ka source ki opposite abdi aina sandagi laiba radiation ji kedowi ha matamda vacuum da ne bala ise ko gyantai ko haisa aduna mangonda any kai abdi kedowa any material ma marakta laiba mathauta deba ko so aduna kedo we have the sida moi ahum se habet samlap na hai matam da ka ten tak na piram ge conduction da dikedo ba no movement of kahani matter hai ge ka no movement of matter or particles hai gi sida na kedo ba sida na movement of particles movement of matter hai ge ka or particles are CI ka and then radiation na kedoba no medium is required no material medium is required ka have the kaino medium dakala ite radiation now conduction ga convection ga the medium dakala ko convection the hit to ga some substance ka dakala some matter khara some medium ama dakala conduction oigera convection oigera ngasai higher temperature duga lower temperature ji ga moini gi marakta iron rod ama leire adu conduction moini gi marakta water leire adu convection moini gi marakta kem leire adu radiation ka medium so leite abduna radiation ka weba gyan tai ta te tai ka and noina khangadamna convection requires kedoba gravity hai ta without gravity there cannot be any convection ka adulai aduna adagi for example let's say sir na noidana okay hesige habda let me ka kedoba noida question ama hange ko question ji kaina hamatam the suppose let's say you have ka suppose you have a flask ka see flask ide yaw ji kaina hot water neba and sigi copper bottle ji de yaw ji na kaina cold water neba ko ani ji hot water ga cold water ga leireba aduga noida kedoba some you have a mug ka magam le do the sida noina kedo we have the flask sigi hot water ji ga cold water ziga si ani zinoina kedoba mix tawgodoineba so mix taw matamda cold water hana hairaga hot water hairaga thakadra natragana hot water hana hairaga cold water kona haira thakadra chiji thanna di thakadoineba and exactly half hairsu yai ko two na mix tawge hargadi cold the hot haigadra hot the cold haigadra
What the call?
hot the cold haiduneba
Cold the hot.
hot the cold
Cold
sure
the hot.
keba
Cold the hot haigani.
cold the hot haigani ko difference in opinion layer was there. Okay, fine. Now, yengzi ko. Kaigumba noina kaidowa. Sigi sida let's say coal lere ko. Coal sida nangna mathakta hot water zi haizen batar gadi kaidongnia. Hot to mathakta dum lere ni coal duna makhada dum lere ni. Yai ko. Aduga kaigumba sigi same thing si noina kaidongnia matamda hotuna makhada lere maga nangna mathakta coal zi haizen bata gadi kedone coal di heavy oina makha da kumdagrane du yam thuna mix tawne ba amna noina cold water da hot water haizen laba thakpa matam da yam sane ba adu ngak le khangi ingthar gi ne ba kaino di temperature do uniformly distribute taw roi ba yam kuina changni ba ko but adi adum di kuina thamaga di distribute taw gi ni kuina di ngatang thamaga di ko adu duna conduction dum tawrakane moi yan dai ga ja abdi adubu we have the convection na di thuba hele ba on convection to honge higher gati hot liquid to da nang coal haijela di coal je heavy maka kumani hotun ka kala ne on moi ni si pull up completely to na mixed over ne ba so you should go for this one ka and not this one aita yar ba ma'am ya de
Yes, sir. Yes, sir.
Yes,
ai
sir.
ka aduna noina we have the morning hadi ayuk ngata hagot paga you should have a glass of water ka ising thakadamneba so ising glass am thakpa matamda lumbu lumbu saba thakpana khwaidai fai kaigi fai no hai matamda nangi body gi temperature do adudagi magi yam kanna difference leiraga thajan budu phatte ba ko aduna kedawi hai matamda again no shower lobo gumbada ising aing mana lujaba kem kai de that's ko aduna hina phatuni but manung de ising thakpai di aing ba thakpa phatte hek hagot paga ko aduga adum ising aing ba thakpa suma phatte hagot paga nati anytime da phatte hata no yam sar kan da temperature control to wai thakpana thakpani ko natragadi lumbu lumbu saba over thakpa matam da ising mix to matam da hot water han hairaga cold water hijalo ko aduna thuna uniform temperature do achieve to ni ba now let's move on to conduction. Conduction towards conduction it's very simple. Coefficient of heat conduction specific coefficient of heat conductivity so for example I have a rod here sorry straight over see or malaka so sumain to road am lay and magi si we have the season temperature is T1 never and assuming temperature is T2 never and T1 is higher than T2 T1 is greater than T2 adu already can have the heat flow to never gyan is heat energy will get transferred here delta Q heat C T1 T2 the flow to ni the aduga anisi eventually mo is equilibrium temperature ma achieve to common temperature ma we have according to the law of heat conduction delta Q by delta T the rate of heat conduction is directly proportional to the difference in temperature the difference in temperature. So again, see T1 minus T2 z aina kayumba T1 and chaw have minus T1 ko. So it's always better to write difference have the kanana chawino achawududagi macha khaidu ko. And then again same sigi pochi ay sumaina yam janjan tongadana basidam torge ko. We have the area of cross section that is directly proportional oi and length inversely proportional oi ko. Aduna sigi proportionality constant to coefficient of heat conductivity ko A by L T1 difference T2 and so on. So this is known as the law of heat conduction and and here the case this is known as coefficient of heat conductivity. Coefficient of heat conductivity
Sir, coefficient of thermal conductivity.
Coefficient of thermal conductivity, yes. Thermal have a coefficient of thermal conductivity. Yes. Conductivity. Yadram yam sige Yarni? No response. Yarni because now again do we have the units and measurement chapter the solve to the Sigi dimension solve to which one of the following gives the dimension of coefficient of thermal conductivity na how do you know coefficient of thermal conductivity ki dimension si kayo ini Hiro dimension of K direct sang here the dimension of coefficient of thermal conductivity K is equal to M the
M
amale ni ko then LZ L square ni sidagi L amana la agadi yentho CC kedoba L am yentho agadi M L amakagla ni ko then sigi sida kedo we have the temperature Z kedoba natin time have ko time si T inverse 2 ni dana adum T inverse 2 le ni ML T inverse 2 le ni aduga sigi temperature si ngaiko sigi T is time ni ko I'm sorry adu ergadi T inverse 3 le ni sigi sida ko energy sidi power gi dimension ne ba marom da haragadi avna T inverse 3 le ni aduga Kelvin da inverse 1 la ni yadra ma'am sigi sa this sir kainu sida su ki hai and haragadi si ki is Kelvin ni ko natragana sometimes kedo theta ju sizina bane ba theta ji kaino temperature ne ba theta is temperature oidiba yarbo
Yare, sir.
Okay, fine. So now let's do convection but convection di toroy kay the convection si di kay we have the question hangingay laite ma di geography go madam adum season ay ka apetan chorok ma di high ka convection adu convection khangaga dina noina kay we have the geology gumba the geography gumba the convection ji khangda yadeba plate tectonics ke ka hapti earth ki plates in move to is kai gino kai na to is simyam ji loina ma convection nga tane ba ko aduna even wind cyclone hurricane blah blah si loina ma si convection nga tane ba ana ke do we have matam the let's say this is let's say this is land and this is kedawa sea nen khala seba ka so kedawni matam the water ga lane si heat capacity ji water ne he leba chawba aduna kaidorakani ha matam da ne water gi mathakta leiba nungsit se si di kai way heavy way cold way ka so here you will have cold air and cold air di kai dawi density is comparatively high way ka and lane gi mathakta kai oini hot air lane kai no di lane di specific heat capacity P eva duna heat ek sunlight ek phang ma jar sagalakani ba amna si di kai ni hot air ni hot air ha di ke do density is lower ni ba ka magi density is ke do my density is lower ni ba aduna di ke do kani have the hot air di ke do ne expand or ma di mathak ta ka hat kra ni ba and ma di makha kum thabam leitam ni na ke do kani som da si gi jaga da la ne ba and then see or pade di ke do ni hot air sa mathakta sum kakhalak padai de haidi sidagi hit pisalak pane sum kakhala di kai orni ma je cold ora ne gan dai ko and then sigi cold air sum cha thokram ni na sidagi di kai la ne cold air sa makhada amula neba. And then CC cold air neba ko. So CC hot air si the expand to ni cold air ne aduga sigi jaga si the som the move to or neba. Yan tai ko aise sumain to ga complete cycle ama CC convection cycle ko eba. Yan tabra? Yan tai ta de?
Thank you, sir.
Tai ko. So sumain convection cycle. Now, CC akwina convection cycle is atmosphere the katanga teba. Earth ki internal layers sing jigi manung da ne. Haidi akwina earth ki keduba. Earth is different plates. So akwina khaidu pe aiba. Auna manung da kedu we have the akwina earth ki crust ki makha the mental the upper mental and lower mental haita ani khaidu eba ko. Ado kedu we have the magi liquid state the ko magma gi form da haita ama kedu we am chawna layba. So CC Kedoni have matamda muisi temperature ji mana deva jaga khara dana hedi kedo we have the can temperature wang ba khara dana temperature ji yam kana wang da bo oye ko aduna maram werga manung the convection cycle leba on si convection cycle ji na maram werga let's say sir na si ji kitang makha dana putharak patar gadi again si si no NEET ki oina bodi kemta relevant oi de ko si gi mathak ji da kai gumba lane kaido ba si gi mathak si dana lane mass ama leiba taragadi kedone sigi lane mass somna move tawgiroidra tawniba so sumain tawduna somdasu lane mass ama legadi mass somda move tawgini ba ko sumain lane mass si move tawgiba taragadi sidagi hot air je lava je kakhalakani ba and sidagi magma do matakta kakhalagadi lava koiba so lava tholadi kai kore volcanic eruption kore ko alain to samudra manung daga volcanic eruption thoga tsunami wave chau chau ga tholaida convection cycle ji natane ba ko on a convection cycle khangdragadi earthquake kamainto or whatever plate tectonics adu da kem khangmangam moidineba so everything is all about kedawa convection cycle haitare ko aduna we have the sigi noin hazizik tammi physics si hayeng wise dum season rakani ba ko aduna phajana makhung sengna tamna ba hono tamni matam da ko so that's convection yare ko now let's do radiation mayamna khwaide tannawa radiation ka radiation jida koina kedo we have the different laws like radiation jida so radiation jida kedo wa koina quite first the radiation is no ye kino gi matung in the dum chamana ni ko common no de male ko radiation black body okay and emissivity do da am nebra power related okay when's displacement low and then temperature maybe textbook ki matung ina kay when displacement low Kirrchoff ko so anyway madum yar se san to pum takselai ka ngai ko no yi textbook ki matung ina kay legam ti yenge ka 1 second ka radiation gi da no yi textbook ki matung ina kay le yenge ka kay mo se do no yi textbook ki matung ina kaido wa black body ke no ko da ne black body radiation or the wind displacement low da ne ko so let's do radiation first now radiation atai ke kama ma kem tak tringe de ko so term khar ta ke ko term khar ji ke no have da sida e so ne e derivative term ge sini ko mun ne incident energy have ma lay ko then ke do ba reflected energy incident energy reflected energy absorbed energy ABSORBED ka energy absorbed energy incident okay I think we better use like this ka energy incident energy reflected energy absorbed energy absorbed ka and then matang ke do ba ye kakta matang dana kai haidino emitted energy haidu ka energy ke do ba emitted or radiated. Yareko. See terms kaisa. See confusion label sungaya deva. See the confusion layer di radiation gyan sumta taroiba. See the clear word di radiation si kedoba half halfway hadi kedoba half journey is completed haitas. And see terms kaisi fazana kena ba khangadam ne ko. So noi see terms si fazana kena ba hande doing khangbra khangdaba mi yaubra. So suppose khangbra hana de see term kaisa. Incident energy na kaino, emitted energy na kaino, absorbed energy na kaino, reflected energy na kaino, radiated energy na kaino je hande dum khangbra. See term ja.
Khangra.
Khangeba ko. Sunanda khangbra, Lakshmi khangbra.
Oh, sir.
Khangeba ko. Saila khangbra.
Khangisha.
Khangeba ko. Okay, fine. Now, so habit ko. Then tag na hierarchy ko. See khangbra gadi yaro. Now, for example, I have kedowa. For example, I have a body. Body imlere. I have a body, and then mangunda kedo we have the ina heat see. Some kedowa heat krala mangunda ka energy. So this is energy kaina incident energy later. Now incident energy see kedoni have the sidai in the chawaya the greatest among all this is energy incident or incident energy. For example, energy incident 10 joules nena khalazeba ko. Adu ergadi out of the 10 joules ka kedoni have some energy might be reflected. So let's say this is Q1 and let's say this is Q2. And kharadi kedoni kharadi dum kedawa penetrate or changrani and that's kedawa Q3 nen khalazeba ko Q3 nen. Now see Q3 sidagi nang na kedoni ya matamda muka energy khara muka mana thadorak pa yaeba. Yan dai guys mana energy khara thadorak pa yaeba duduna Q4 ne. Gyan taita de taiko this is Q1, this is Q2, this is Q3 and this is Q4. Now kedo we have matamda Q2 na chawge na chawrabada kedo ba Q1 ga chawba mana bi kaigumba if no energy is absorbed ko loinama reflect to thokiba energy is absorption to hodaba kyan dai ko isa do go with. Let me just ask one question. Energy is emitted energy ka reflected energy ka habidi kedo ba managadra manaroidra Manaroi buka. Okay. So karamane chawni always emitted energy and
Reflected na dum chawni.
reflected na dum chawni buka. Okay, fine. So adul laite ko emitted energy ka reflected energy ka si reflected energy na chawni have laite pickani have laite. Gyan dai ko aniji ado kenari ji kai the kenari no have matam das. For example, I have a body ko, I have a substance, and mangonda kay doni have matam the some source tagi energy kara mangonda kay dore kay dowe hay dino kay have a
Incident.
very
Incident.
sir na jikta kay dowa sida high gi terms kay do energy kay hay incident hay ba energy kara kay dowa sigi body sida incident to hay dine ba. Now incident to riba energy sida gi kara amadi reflect to thokrani ba absorption to horoi ba reflect to grani thakto ba and then reflect kara to thoni lemo budu no man absorb to ba. Now absorb to riba energy du dagi man amu kara ama ke dorani emit to rani ba emit to baga radiate to baga chap man ko ado kai gum man absorb to rib do loina mak thadora gadi emitted energy ke absorbed energy absorb ka man hai du ne ba ado temperature kedoba change layer temperature increase to roiba kai gumba man absorb to una 5 joules of energy absorb to raga 3 joules khatang ka kai toropa emit toropa or radiate toropa emitted energy or radiated energy chak manai emitted energy kya 3 joules and aduga absorb energy or energy absorb na kya 5 joules on 5 joules of energy absorbed and 3 joules of energy kai emitted adu ergadi the body will kedoba have an increase in temperature. The body will show temperature rise. Gyan tai ta te?
Right, sir.
Tai ko.
Tai sir.
So adumaina laigadoineba. Aduna adugi khenabdu khangoba ko. Kwaidai chawbusi si myamsida kanano haragadi incident energy sineba, energy incident. It is the ultimate source. And energy kara body in the incident actually again according to study to is with respect to a particular body amagi respect and study to the mangon energy kam incident actually and incident to river energy to the out of the total incident energy kam reflect over kam absorb to then reflect to give the lower echo mangon the thokram na man absorb to hodram neva tawraga thadorakpadudi radiate to hai reflect to hai deba reflect to hai di absorb sung to dringai da incident ek to dum thakto ki mangon the sungchang changak teba ko aduna that's reflected energy and then mangon the chang give sarup tuna absorb energy mana loction give duna adu mana thadore duna kai doni ha mata aduna kai kawi emitted energy or radiated energy neba emitted energy or radiated energy ga energy absorb ka magi magnitude manani ko temperature increase like magnitude manani but moini gi frequency and wavelength to adu radiation adu gi managadra have the laite manani have laite ko but the magnitude of the total energy absorbed and total energy emitted or radiated is equal ko it has to be equal if there is no net increase in temperature sir na haning is kyan tabra
Right, sir.
kyan tai ka okay fine so now let's proceed ka adu gi kenab du khangadi now let's do black body ka black body as you know
Substance, any radiation of wavelength, any lining, wala I absorbed or completely absorbed.
No. Do ya do we definition no can oide ka clearoid do clearoid of the natil chum de ka atopadi say the boss what is a black body
Sorry sir.
okay khang de ka Lakshmi khang bra Lakshmi sing asing ngasai di sir na ko je sung kumakte Lakshmi kenu tok da bra Lakshmi je masangam di ro natraga kenu yad ri ro mai ja phone yad bra Lakshmi ji badi me the tadre ko sir na nangi mic yad da male Lakshmi anyway kenu to okay fine so black body si kaino Anjali Saila
perfect absorber oidineba adu emit tawdeba ando manungduda dum
okay manung
perfect absorber
absorber or perfectly
as well as anima hadi emit tawdineba
natragana emitter haide ko
absorber as well as perfect emitter
okay fine very good ka black body has kaino have the perfect absorber okay perfect absorber ka or perfectly again kedoba emitter emit tawba habidi kedoba energy mana absorb to khuding mak sa ma temperature increase tawdaba taragadi loina mak thado kadwine ko emit to thokadwine ba or perfect radiator has ya ko emitter ga radiator chamane ba but again perfect absorber adu di black body gi magi essential criteria ji kaino habida black body emo yi haragadi kayo ne magi energy reflected is equal to 0 aita habdi no energy is reflected aduna black body amda tasaliba incident energy do adu du kai dorakani habda reflect sung to roeba loine mak absorb to giniba aduna di amo koina kai habi yai have matamda in a black body for a black body energy incident is equal to energy kari energy absorbed yai ko And again further, again energy incident is equal to energy absorbed is equal to energy emitted. Gyan taita de taiko sumaina legideni no si conceptual clarity je leiragadi noida ina makha takthaba lairani si hek sengraba Kirchhoff's law takpuji yaroi ama takpuji yaroi adum noi dum nga leirani ko adugine dana si auna noi black body the khanga du ji kaina energy reflected is zero ne energy reflection to deba aduna black oiba substance kai ji black body rana nai khalagadi black oiba substance khuding makti black body di natte but kay di koina hadi again perfect black oibanga magadi ko adiragadi koina potu lay have kai uroi dine ba ko yanda rise aduaina so aduna koina black body si kamaina design to we yai kaina ga hay matam da suppose let's say body amagi sumai lay re ba ko and mangon ke do ba ko tang ye ke fazana ko body amagi sumai lay re mangon the whole am lay re ba ko. Okay, there's a cavity, but again, so let's say there is a body and there is a cavity. Cavity have the hole, a hole later. Then we have the light, the hole, the power change, the strike tore. Then body is combine design to we have the sigi bodies. My sumain to sumain to lem, and then I do not. My body gi manungi structure ji sumain toraga sumaina ke no honde yan menta da video ko sumain am toweba auna ke only have the light rays ji sida change sida yeire then sida yeire sidong yeire sumain toraga manungi da ke do ba sumain ju madum chatlaga leire ko yan menta da video aduna sumain dum chatlaga leire so ke only have the light tholopung ngamdre ko so adu ragadi ke do rakani have the incident energy is loine absorb to graneva loine absorb to energy and reflector of treva adudi ke doni my temperature increase to kaneva my temperature increase to kuduna maram or maji ke doni have the energy thadora neva on energy ke dorani emit or radiate to raneva so the emitted energy or the radiated energy should be equal to the energy absorbed kaiguma my temperature si net temperature increase kaimta lairoi ge haragadi gyan taita de
sir.
taika
sir.
Okay, fine. Lakshmi gi headphones gi mic gi address. Okay, Lakshmi ya sir nga sa nang ichechi uhog ka. So further makatar poina let's do black body radiation ka. Black body radiation to gre Wein's displacement lo to zika. Like Wein's displacement lo to ding the Kirchhoff's law mathang da Wein's displacement law mathang da Stephen Boltzmann's law to zika. Duna before we do Wein's displacement law, we'll do Kirchhoff's law ka. This is Wein's displacement law. I see tawgiro ye ka asum asik hana thamora ban. Hantaus kay hantaus ba Kirchhoff's law hantaus ka. C double H oibra C H O double F oibra. Ka. I think C double H oibra mti yone. Again
C double H duga F so.
C double H O double F ka. Okay, fine. Now alright, got some can talk with Lani, even though I didn't talk with one in car. So have the my spelling do one but again. Now Kirchhoff's law na Kirchhoff's law is the tapping a the no can hana talk to the absorptive power, emissive power ka emissivity and do we do han tak to the right? I do not the Kirchhoff's law can again ka. So absorptive power han tak ka. Yes, on space later. Let's do absorptive power. In spellings, sorry, absorptive power absorptive power Z, I think it is given by A ka. Absorptive power Z A, and this is kaino hai matamda energy energy kidaba absorbed per unit energy edena have the out of energy kaino incident have the, let's say kayumba body amada 10 joules of energy see some source they lie and body the incident or energy is 10 joules of energy incident or body amada ko adu out of that 10 joules mana kayumba 9 joules absorb to my absorptive power is 9 by 10 I didn't 10 joules mak loin absorb to black body all my absorptive power 1 tabs black body oy kayino energy incident to energy absorb to energy incident ka mana khala gadi the my absorptive power is 1 ta and black body has an absorptive power 1 ko adain to na dagi all other bodies see energy loina ma absorb to wangam de energy incident to the kharam di reflect adum to gani aduga lemhuri pot man absorb to gadoine ba ko aduna absorptive power is always less than 1 for any regular body ko other than black body sir na haning is gyan tai ta de
Tayo, sir.
tai ka
Tayo siya.
okay fine yare ka matang torzi now sir na kitang kaino henjin na ta amni ko na gi kaino gi si yaw na kishu khai di kaino to bu chang bu na te ba ko dagi matang dina kaino emissive power ko emissive power jina kaida wi ha matam si sima kitang phakta bani ko moneo energy emitted per unit surface area delta S let me use delta A and per unit solid angle omega ni ko and per unit time sisibu kai koi emissive power of a body ko gyan tai ta de tai ko sisima khangjal lo and then emissive power ko thang da kai no emissivity is a small e oi ko my symbol sa emissivity di kai no have the emissive power of black body divided by emissive power of a body hai tare ka emissive power of a body with respect to the emissive power of a black body hai ta ka dan nei do so ai sida kitang kaino to daba ngai daba horamani yabre ong mem sigi se now sigi mari sigi ke doba ahum sida noina gyan ta daba yaw de hero sir da ko aduga kaino to ke sir dum hera ke ba ko absorptive power energy absorbed by energy incident le emissive power na kaino energy emitted per unit area per unit solid angle per unit time ko so sisina ke do ya matam da kaino ni ko now energy emitted per unit time the power neba so power do with respect to per unit area per unit solid angle hai du neba ko and then emissivity na kaino hai matam da emissive power of a body divided by emissive power of a black body oi gdo neba ko emissivity is now si ahum si phajana gyan tabra gyan ta da ba mi yaubra habidi karamba du kaidoni sir na amka explain to ningi sunanda yadra yani buka sai to bos yarbo
Sa emissive power yung to hai.
karamba ba emissive power hai
power.
emissive power hai bese emissive power hai si kaino hai matam da ngasai gi aina ko kai hai si ga som da tawsina sumain leireba body ama si da kaidoni hai matam da energy si mana absorb tawgreba ko energy khara quite first the energy incident tawrani energy khara incident tawrani out of the incident energy khara reflect tawgre khara absorb tawgre and out of the absorbed energy mana amuk kaidorakani have the energy jang thadorakani ba gyan dai ko haise energy amuk mana kaidorakani thadorakani ba thaktorakpa nate ko thadorakpa thaktorakpa duna reflect tauba absorb sung tau da bida thaktoki biduna energy reflected ko ba energy thadorakpa hargadi kaina emitted oidune ba emitted or radiated china magi manung dai thadorakadune ba ngasai absorb taugiba energy da manung dai amuk thadorakpadune ba ko emitted haise so emitted energy is energy kayam thadura e have is magi any body gi surface area the per unit surface area amadagi energy kayam thadura e energy mayam thadorakpra kitang thadorakpra or sigi surface area ji per unit solid kedoba angle hajina asigi solid angle ji the kayam thadui kitang thadokpra yam thadokpra haibado adu do neba and then per unit time tapna thadokpra yang na again it all depends on frequency and then kedoba haidi intensity lom da laga nang sagi area ga solid angle ga duna intensity da intensity ga mari lainarni and magi per unit time duna man thado radiation du gi frequency ga mari lainarni ba ko so sumain to raga man energy thadokpa matam da body amagi emissive power yam chawraga di mana per unit surface area of the body per unit solid angle per unit time energy myam thadokane gyan dai ko adu du bu kai dawi emissive power yam chawba ko weba and kedoba yadra du dia
Yani sir.
yani ka atai di
solid
Ah.
kana angle
hero
oida.
hero kay haban jili
solid angle haida
solid angle have
solid angle do
ah okay fine nang ise solid
Ano
angle si kyan ta de haraba solid angle si explain to bi haraba
do kay kari angle
solid angle si ko angle si akoina two dimensional angle si line ani marakta lei ko sumaina line am leire sida line am leire ani ji marakta angle theta lei bi bu solid angle ko wi ko aduga for example nang na cone ama leiba matam da let's say this is a cone ko aldi si cone sida subscribe to riba solid angle si gi angle je si bu omega solid angle ko eba gyan tai ko cone gi shape ta lei roidro ma je
hojiki kano do
hojiki si sida natra si sida any na
sphere da already guide my solid angle to guide oida
sphere do or su kem kai di sphere then for example nang na center dai lauraga su adum any sigi area ma lo matam na mai center dagi solid angle kam form do we have the nang area do sauraga di su ai di nang na yam chauna lauraga di solid angle saurani area kitang oraga di kitang lorni yarbo have the solid angle have the ngasai cone gi shape ta lei duine ba ko cone gi shape ta tasal laga manung da form to angle du solid angle ko mari 3 dimensional ne ba angle je chamane ba ngasai amazina chumna gi plane angle zina 2 dimensional oi ba 2D da lei ba solid angle di 3D da lei ba yarbo
yani yani sa
duga sarna kai umanoida if I have chance na chagana sida di takunu aitre match ki class gumba da noina ngasai circle ga sphere ga ji kya mane ya jinoi gi solid angle plane angle ani ji compare to matam na formula me am ji ma pam pa po long noi ta jara kani ba di kai gumba ha di noina ke do we have the circle gi circumference 2 pi r oidana ko aduga sphere gi surface area na 4 pi r square oidana now solid angle 4 pi oiba odagi plane angle dana 2 pi oiba kaina ga ka the complete angle do adu sing do compare to raga loina ma do ina compare to we ya bane ko adu sida di discuss to ro si ko we'll do that later now so sigi hum ji phajana khangaba khangdabra sa haina ro
Khange sir.
khange ka adu ergadi let's do Kirchhoff's law ka Kirchhoff's law na hai ji kaino habada emissive power of a body sorry kedoba emissivity hai tare ko emissivity of a body divided by kedoba aina hai sorry emissive power of a body divided by emissivity of a body as black body or geramo we don't know any body ka is equal to kaino habda is equal to emissive power of black body in ka is equal to emissive. Why am I writing the word emissive power of black body? This is known as Kirrchoff. Okay, ba?
Emissive power body higher divided by absorptive power
Absorptive sorry, I'm sorry. This is absorptive power. Emissive power of a body divided by absorptive power of a body. This is equal to emissive power of black body having a book. Now, CC kamaina la ino have the hierarchy. Let us consider two bodies identical of a body. Identical have the same shape, same size, but one is a normal body and the other is a black body. So let us consider two bodies. Body ani lay ka. Sisina chumnagi body ne sisina, and this is black body. They have the same dimension. Habidi moigi diameter or moigi thickness or moigi size, length, breadth, height, whatever my shape body dugi magi kayani kaino dugi matungina my structure dugi matungina laiba dimension da ani mak chap mane na kuin lower ni buko adu ergadi akoina sigi body zigi kaino left hand side Kirrchoff's law gi left hand side lai je kaino yeng ko sigi law je understand to khara wa bane aduna munna taw noi phasana gyan tani ngadi ko natragadi miss tawne ba adu kitang nungai tabane ba ko swaise di nungai tamne di for di kitaw no gi like te ibda su phasana I dabani aduga angangai na su kitang ai asum sir gi experience angangai khara no hanjan explain tawdadi yade ba ko aduna munna taw ba ko so kaino have the kai secret pointer da silai ka on CC chumnagi body amani and CC na black body amani so left hand side la isina si body zigina left hand side ta or si adu same black body zigina right hand side ta or si ko kai first la isi kaino CC kaino emissive power of a body ne ko si hana storying si ko now left hand side storying si left hand side ta kaino la isa emissive power of a body है का now emissive power of body z aina तब मतम द कई लाकने have c is lakadoi ka so I will just write like this delta q divided by delta a delta omega and delta t time ni ko delta t se smile ne and then makada na kaino have the absorptive power of the body. Now, absorptive power di kaino have the sigi ngasai ke doba energy kaino emit energy absorbed by energy incident have ne buka so adu di kailani si sida this is delta q ka si sina kaino emitted ka sina kaino delta q sina kaino si sina absorbed yengu ko yamunna yengu divided by delta q kaino mazina incident natra mani incident hai tare ka emitted absorb incident so adu evitar gadi akoina kaidoni ha matam da ka sigi makhazi mathakta ka khatkrani hai tare ka auna ultimately sigi kai tare ke do yengsi ka munne kaidobagi black body ga dum kaino tawduino do chamana duino do ai sigi kitang chingat ke natragadi yaro makhai chingmu ka amusing tare ke kona si le si yun singat pa ng far ni ka ya si ya ka so si le adu ergadi noina sisi kai lakani habda sigi noina na sisi ga cancel sa yabra no response yabra the bro
Yeah.
yai ka adu ergadi kai tare ha matam de energy se emitted energy si energy absorb ko always mane ba kai no di mana thadora kudribe energy se emit tꯧthoktoiba energy si mana absorb taugiba energy duneba gyan tai ko aduna energy ke doba emitted is always equal to energy absorbed adu di ke dora kane have c tare now c di kai no energy incident divided by per unit area per unit distance adu di c di kai no have da c di black body da khatang true way c di gyan tai ta de normal it is norba
ngaude sir.
now they got okay great. Now this is equal to kaino have the emissive power of a black body. Kaino because since for a black body space is is for a black body has natragana kaino higher ko as for a black body ga higher chandre ko I channa batoragi ko since higher energy ke doba delta q ko energy emitted is equal to energy absorbed is equal to energy incident for a black body that yan taita de taiko
Yes, sir.
okay fine we do gyan targadi that's it so cc niko again cc this is for a black body niko then no inkanga na okay for a black body for a black body ke doba energy emitted is equal to energy absorbed is equal to energy incident cc black body dadi loina mak mane adu energy reflected is zero ne gyan butaribo
Yes, sir.
ito post
Right there.
taiko okay fine great now so is ikra nungai na dabni ba ko mayam na tugi ne sir na hajan explain to is ka si yam phajana khangba mathau tai now this sir sigi small e di kam kan sin na duino on higher gadi small e is oxygen rani kaita Stephen's law the sinner kani ka Stephen Boltzmann's law the small e sinner kani aduga adu law adu tor siko je Wein's displacement law ga Stephen's Boltzmann's law ga tawsi ka Wein's displacement law da kay lay ha matam da tor siko frequency ki graph to yes yeah but anyway now let's say sorry ka sisi da swai de le lage matani sina ka magi keno ze temperature ka sumai lege duni ka duna sisi kaino have matam da again sir no the hydri ko kemta duna no kitang kena to mani normally but don't worry ka I'll explain don't worry so let's say this is T1 this is T2 and let's say this is T3 and this is lambda 1 this is lambda 2 this is lambda 3 so lambda 1 2 3 high with the lambda I sumano in high ka maximum frequency lambda m1 ka hage lambda m2 hage this is lambda m3 hage ka aduga condition ji kaina T1 is greater than T2 is greater than T3 haiduneba ka aduga sisina kaina habata energy density hagadra energy density hai tare ka density so I'm paine e ngam and this is wavelength this is kaina emitted wavelength hai tare ka du sisina emitted energy density ne ba ko sijo emitted ngatani ko anima so sisi kamai phaina jinga pusidi kitang phakta e phaina easy ko energy hai dinesis yare ko so this is energy emitted kaino into is energy idemani emitted hai si emitted is easy copy toraga si layer is na kina quite far absolutely ko emitted energy density sina emitted wavelength yare ko auna yam munataro ko engatang si stop to zira stop torage sign torage body yam le ko body yam asida ina ke do ba heat pisal leba gyandai ko heat pisal le adu di ke do rakani body ji temperature increase to kani ba to kani to roy no response
Tawagani sir.
kaiba aina body yam de heat pisal la agadi mazi energy absorb toramnina my temperature is increase to kani ba ko now my temperature increase to pajima energy absorb to re hai ne ba adu ma do we have the magi ke temperature increase toning bra hai ma toning de ba my surrounding the same temperature the lining ba magi han laserum temperature da dum lining ba aduna ke do kani mana energy radiate to kani or energy ke do kani thador kani ba ko energy mana thador pa matam jidane ke do kani ha matam da particular wavelength ama khatang da thado kadra har ga di thado eba all kinds of wavelength different types of wavelength da thado rakani ba adubu at a particular temperature da mana thado iba wavelength to adudu wavelength am di yamagasu wavelength amadi aduki matik maximum frequency da have de aduki matik mayam thado kani ba aduga kedo we have the remaining wavelength to yam thado eba ko for example sir hage ko ta I should explain to you again da ko war mani khang e dane phazana explain to this stop share to ko for example let's say sir na sigi se ko your opinion ka sisi yot nen khala je ko iron nen khala je now sisi aina gas da natraga na mai yam kan ba flame ma da ko mai da aina sisi hit to re ba hit to ko matam da magi khoi first temperature si kai han la ka ne sisi sum sagala ko matam da no response sigi yot se this is sisi kai do we have this si yot se aina hit to re ba ko yot ne na khalo ba sisi aduga aina sisi yam na kan ba flame ma da mai yam kan bam ne hit to matam da ihan han da mai color si kai han la ka ne red oigadra blue oigadra white oigadra green oigadra yellow oigadra kai oini sigi se red very good red han la ka ne ba ko ngatang le ga kai la ka ni red tagi sum adum hit to saladi red tagi kai dong change to ka ni
Orange, that's right.
okay orange or yellow or whatever yellow gum la ka ne ba and then sum hit to salagadi kai da change to ka ni blue da change to ka ni au dai sum am ka hit to salai kai da change to ka ni white da la ka ne ba gyan dai ka white nearly white hai ta gyan da bra da intorga so cc kai no have the again akoina u da ba magi wavelength mayam am su lay ba ko adu di akoina khangma ngamaroi but kai akoina hit hek to ga mayam thadoi ne but akoina u da bai wane ba ko so akoigi blue ga red ka ko lakshmi jet ta khume ko okay lakshmi blue ga red ka se red na han doi ni blue na kon doi ni ko so quite first red han la so red han la paduna haining is kai no haiba matam da sigi yot se ko iron rod se aina hit to matam da mana red oi rei do magi wavelength to red ki wavelength thador pai ne ba gyan tai ta de tai ko mana thador iba radiation do red ki the thador ado red khatang thadok pra hai red khatang ni thadok panati adin different types of wavelength ma'am thadoi but kwai dai hen na red ta thadok gi red oina ui ne ba koina si gyan tai ta de tai ko mathang da yellow rai si kai gina habda kwai dai hen yam thadok pa je temperature increase to ko matung ina yellow amu ore ade khara gang temperature increase to ko matung ina blue amu ore so blue thadoi the blue wavelength ata thadok pra di no thadok te ba blue red chu dum thadoi or the white chu thadoi but blue na kwai hena yam thado ga di maximum energy density hai tare ko adudu kaino ibaki blue ibaki koina kaidoba haidi magi wavelength to blue gi wavelength lei be koina blue ina ubane ko sumain to duna kaidowi ha matam da som side to lei ji kaino emitted energy density is a temperature ji kaidoni have the temperature low eragadi magi wavelength yam chawe ko temperature sum increase through matung ina magi emitted energy density hengalai and then magi maximum frequency wavelength haigadra kwaidagi yam ba wavelength to adudu sum handare eba aduga noina su aduga noi sima su khangjalu ko energy E have of a radiation have it is directly proportional to my frequency neba and energy of a radiation is inversely proportional to wavelength neba gyan tai ko aisa aduga adu ergadi kedoni ha matamda again E is equal to h nu kind of lay ko so adu natragana hc by lambda blah blah adu duna tongan bam leigre cnism khangjalo ai atopa mayam duna modern physics ta ke ko magi kedoba corresponding kene my chapter do da my respective chapter do da dum talake so sigi sinoi gyan tabang ambre yango magi wavelength my temperature T3 oiringai matamda wavelength to yamna sangni ba kai no matam noi sigi matang sida electromagnetic spectrum gi knowledge sam ju darkar lei ko electromagnetic spectrum je hepet high ge yong ko sida is short form the era ge sum sang era ko electromagnetic spectrum EM spectrum har ge ko electromagnetic spectrum zida quite first magi kedo we have sorry okay energy quite the chaw ji kana no gamma ne gamma is cosmic so have ko gamma le ne then gamma dagi frequency picture up or energy picture up ji kana no khangbra x-rays dagi frequency or energy picture up ji kana
UV rays
UV dagi kana no visible or vibgyor hage ko then sidaidi kaina lay
radio infrared
kana lay
radio waves microwaves
so daidi kana lay
radio waves
ko so sumain lay dune ko aduna sisi kaina the decreasing order of frequency neba increasing order of wavelength higher gadi or kedawa increasing order of wavelength na cc kaino this is for frequency atare ka frequency gi oina di sumain leba now wavelength gi oina di kai leni have the radio na kwai dai chaw radio mathang kedawa micro la ni micro mathang infrared la ni ka infrared mathang kedawa kai la ni vibgyor mathang da UV la ni then mathang da x-rays la ni ka okay si matang di sir na kara ko haining ba ka le higher di ngasi class e question mangam marai di yam nungai ba topic ne si gum li-fi kai ka ma sir na project kai kino kara angang science project gum ba dai sa gi sum nungai je bi ta ko kara sa ba ko pam je ba ta da inte so anyway okay do we have the kai ni si kai thang do kra ya thang do kra infrared okay anyway so sumai leiba sisina kaino lambda sina wavelength ni ko duga news in a frequency ni ko sisi makhangjalu natabi da kaino na tawlem ni ko yanwai kaino si to ijibo na anyway I see kitang matakta sakat ke electromagnetic spectrum mai ni ko si ja this is electromagnetic spectrum 1 second duga sisi ay kitang thangdok ke ni hena clear on what this is frequency.
Sure.
How?
So frequency ga lambda chap manadar.
Frequency di mu.
Wavelength gitu sir.
Onnaba male.
Adugi less than idu greater than idu natro.
Oh, chumi. Aina si direction change to thori ai berani. Ka. Okay. So my native ka. Okay. Thank you, Kane. Point out of it. Thank you. Now, ꯑꯩꯈꯣꯏꯅ ꯍꯧꯖꯤꯛ ꯁꯤꯖꯤꯟꯅꯔꯤꯕ communication the same as radio frequency or radio waves or keno ngata neba sigi radio gi wavelength se si sineba ko akoina RF kaina ga hainab the radio frequency haineba so akoina zik seasonary ba bluetooth 2G 3G 4G 5G even 6G tholaga zu loinamak radio ngata oitineba yan daita de tai ko auna again noinaga noi mapandaga chalagadi metro card natragana hajikan chip nung ama swainaga tawraga scan tawba yaba whatever scan tawbadi camera na natte ko ngasai gi QR code ki wari natte baina just near field communication and NFC kainaga hajikan card ta chip hapsin ba kochan bi adagi even kedowa keno tawba even mind akoi brain da chip hapa kainaga neural link kainaga tawraise whatever siguma myam ji kaina da si da ngata ne radio da ngata ne. So sometimes no celebrity a pow ko leram asum 5G gi matang da si thola gadi ko human being ji on cancer pok ta adu da ode kai myam thola ni kola ni adu da kai yam high bane ko so adu do policy amane have the ke do misunderstanding ni moi ta sena khang da bai ne ko loine mag radio frequency nga ta ne ba and radiation amagi magi kahene harmfulness haigadra mana ke do ba son mangam ba za my frequency na suan doine wavelength na suan deba ko frequency chawrige sathi ba gamma guys kidawi atom bomb thada the gamma produce tawi numit tagi produce tawi and kedo cosmic radiation jana mana gamma ko yam thina sathi ko ana koina space suit hek yawda bada adum koi sor hon da su hingba ngam en khala jeba gamma nam chakthi si ni ba and then x-ray yam sathi yam toin do phatte x-ray makal lei ko koi body da copy x-rays di khara phaba x-ray ni yam kana sathi da but x-ray sathi di koi kedawa once copy the skin ji pura kai di kedawa skin ji sihan bangam me ko x-ray sathi uv ji dum khangam mani ko uv ju phatte ade koi na kedawa vibgyor ji de koi season nei ko koi na vibgyor leitragadi we will be blind haita human beings kai di blind or ni vibgyor ek leitab da kai na koi gi koina kedowi koi human being gi koi gi side se ko mit na uwa ngam ba chang ji sidagi hena hengal la sungam de handar sungam de but atopa jiba kai ding ngam mi ko sidai hen ba da ngam ba jiba lai sidai handar da ngam ba jiba lai hodong gumba snake gumba hefdi moi di amam ba da uchi nung phadan ko tana or even red uchi ma sama or moi ji kedo infrared u ngam me ba na moi mami chil lang khat pane ba amam ba ko amam ba da infrared sense to ngam me ba akoi ding ngam de ko adule and then micro then radio so my leg to ko so see ma'am see this is electromagnetic spectrum certain class 2 of the electromagnetic spectrum man chapter am yaw em waves na ko adu da ko na to kani but see ma chok khangjalu cc ga combine to ga relevant ori no har ga di wavelength si sum picture ge kedowi energy chawe ba wavelength picture ge wavelength sum sorry see the frequency ni ko wavelength sum picture ge kedoni energy chawe ba ona energy si temperature hai dune ba adu manai ba ona wavelength picture pa hai ji ke no abdi magi wavelength sum chokhala ga di temperature handarakani wavelength picture ga di temperature increase to kani hai di corresponding do temperature chok kani ba gyan taita de ma'am tabangam bra ngamdabra ngammi ka okay fine that's great so that's Wein's displacement law adu noi wadi waramani macham tanga take ka macham tanga and that will be Stephen's Boltzmann's law ka tungje the call jula alarm ju khonge but anyway Stephen's Boltzmann's law tawzika now noi sometimes noi sangba matamda Boltzmann gi wari ge je pau ko Boltzmann ka amna apawa scientist ni ka mazi kedawi have the magi contribution ji akoi yam pakna mayam yam chaw contribution ni but mazi yamna nungai to mo de lei gi de hatare ko mayam mazi gyan ta ngam da bida kon Einstein hoina ko Boltzmann gi kenozi mayam the scientific community da Einstein proof tora kanda amu hen phawgalakadune ba ado mazi even depression gan hadi keno to hadi magi poto mayam na khangbi da bai tare ko habiti lala boy edi kene understand to ngam bi da adu matam da adu hairaga Albert Einstein su my theory of relativity da Nobel Prize phangi de ko photoelectric effect explain to budaneba Albert Einstein na Nobel Prize phangi kaigina habda ma hingingai matamda habdi adui matamduda haitare ko theory of relativity ji yamna di phazaragasu kayani scientific community ji convince we what ki bai ta aduga photoelectric effect explain to wei ma Nobel Prize phangye relativity gi di phangde ko adumaina sigumbo wari nuai nuai leibini ko noi sangba matamda hajikti gi yonginu no hajikti pekha da focus to kayumba aina jik sarna jikta isi 11 12 ka ba student na yengba taragadi noi gi you have lots of time ko ample time lay no you can surf haitare internet adum thiraga yengo ka anyway Stephen Boltzmann's law tawsi ka Stephen Boltzmann's law na hai si kaino hai matam da energy radiated ka delta q per unit area da a hai ja delta a n per unit time delta t is directly proportional to fourth power of temperature. Ay nga ko, Wein's displacement law di torom drain to is Wein's displacement ho wala me. Okay, anyway, sila ko. So kayo have the kayo ba maximum wavelength. Maximum wavelength have the wavelength am chawe have na te ko. Kwai degi thado yo wavelength to. The maximum wavelength which is radiated hagadra ko or kayo ba emitted wavelength मैम दुई मरक्ता ख्वाइदे हेना याम थादोरक्पा wavelength am yauni bka adudu kaidoni have it is inversely proportional to temperature sarna jikta haigre ko temperature hengal agadi wavelength handarakani na so aduduna it implies lambda m into t is equal to constant and that constant is known as Wein's constant haitare ko so this b is known as Wein's constant Wein's constant ko ka T A N T. So the law is this lambda m into t is equal to constant. Gyan taita de ma'am. No rest.
Hi, sir.
Taika. So okay fine. I do sir di kedo basigi na b values I recall to dreno khang mami yaubra. B values b is equal to kayo
2.89
2.89 okay
into 10 to the power minus 3
into 10 to the power minus 3 kay
Meter Kelvin.
mk
Meter Kelvin.
meter Kelvin. Okay,
Kelvin.
fine. Okay, fine. Meter Kelvin. Okay, fine. Thank you, ka. Dule. Sisi mazu khangzalla. Matangda sigi sima tawraga ngasi class loshalaji ka. So sumain lerni. Auna so delta q by even delta t is equal to noinaga kay have the Stephen's constant sigma ayraga kedoba again a sometimes no a and you think nani delta a has t to the power 4 so manga thing na but you should also use e haitare ka duna sumaina ngai ko a sumaina e ge e t to the power 4 haige ka is equal to sigma e a t to the power 4 so this is equal to lani ka sumaina t to the power 4 natragana yare sidum yare ka aduna sisi kaino habda here sida leiba delta q ji kaino delta q si energy kidawa emitted or radiated haitare ka and si time lere ko e jina kaino this e ji kaino kaugraba kayo dino
Emissivity.
and what is a in a to the surface area ka that's the surface area and Td cannot absolute temperature. Absolute temperature is the Kelvin Nika. T is absolute temperature. So now see the sigma की value से क्या नाम था
5.67 into 10 to the power minus 8.
5.67 into 10 to the power minus 8 K.
W
What?
emit
K.
Per meter square.
K hai no. W K.
meter square inverse.
Meter square inverse. Sumaina lebra.
Ama
Per
per
meter.
yaude per de lauthokidaba ama
Per hairamnina. Sumaina dum hairge ka. Sumaina dum hairge ka. So watt per meter square. So sumaina to C is in a sigma in a Stefan's constant ko eba ka.
Kelvin to the power
Okay, and Kelvin to the power K.
4.
4. Yes, Kelvin to the power 4. But okay. Makada layer na per diagram ni ka. All right, yeah, chume. So sumain layer ni ba ka. Now this is the A is ina delta A ira gana no idum si the delta A iro A dan iro ka. Sumain to this is known as Stefan-Boltzmann's law, and si the haining is ka ina the body amna energy kayam per unit time emit tauthokani or radiate tauthokani have dune ba ka. So adugi do magi kedugwa my fourth power of temperature da directly proportional oi magi surface area yami gay energy yam thadorakani and surface area this is directly proportional oi and small easy kaina emissivity yam wangi gay yam thadokani emissivity p agadi yam thadoi but sisi kai gumba black body oi bata agadi kai oine small easy yaura roi kai gino di black body gidi emissivity is 1 type ko aduna emissivity yaura roi sigma at to the power 4 and hairane yan data de
Yes, sir.
like on a for a black body kai dorakani have the C yaura black body nattaba taragadi yawni ko but black body gidi yaura yarba ma'am sigise yarbo
Yes, sir.
yarni ko okay fine so adudi keno tawni sir gise ngasi again Newton's law of cooling do next class ta orji aduga numerical ma'am do next class hot laji ko so nei sir gi theory ji nei na gyan taw to ba yar ga recorded session dum tang gi yengo aduga pyq angam ma practice tawro noina lugani khan ba pyq ga solve tawji aduga noina pyq khatang nate any test anywhere noi je gi question hoigera NEET ki question hoigera any question sigi topic sidai si chapter sidagi yaur gadi noina gyan ta da le gadi heyeng sir gi class puro sir solve tawbirage ko okay fine so let's call off for the day thank you everyone ko have a good night
Thank you, sir.
okay
Good night.
thank
Thank you,
you
sir.
and good night ko good night